Welcome to Chemistry with Caroline. In this video, we're going to look at the hydrogenation of alkynes. I think for reference, the review of the hydrogenation of alkenes will be helpful for us here. So if we start with an alkene, we add H2 across that double bond to get an alkane. The hydrogens are added to the same face at the same time. So we see a syn addition. They're either both up or they're both down, and then they push the other groups in the opposite direction. Okay, so we're going to look at adding H2 across an alkyne where we have two pi bonds and the different ways that we can control that reaction. So let's first look at an example where we add excess H2. Okay, so in the presence of the palladium catalyst, which helps facilitate the delivery of H2 across those pi bonds, if you have excess, you're going to end up adding two equivalents of H2 because you have two pi bonds. So I'll get a total of 4 hydrogens added to the molecule. So one equivalent is added and then a second equivalent. So I'm going from an alkyne to an alkane with this reaction. This is a reduction reaction because I'm adding hydrogen. However, I might not want to go all the way to an alkane. I might want to stop at an alkene. And if I do that, I can't just have H2 in the presence of palladium. Palladium is a good catalyst and it will facilitate the addition of H2 across pi bonds, whether it's part of an alkene or an alkyne. I can, however, include something called Lindlar's catalyst, which basically poisons the catalyst, makes it less reactive, so it will only add one equivalent. It will just react with the alkyne, but not with the alkene, so I can stop. Much like with the alkenes, the facilitation of this reaction, the delivery of the H2 is syn. It adds to the same face at about the same time. And so what we see is selectivity for a cis double bond. So your H's are going to get added to the same side at the same time so that you see cis stereochemistry, but you don't see any product formed where you have the trans alkene. So this is nice because we might want to make a molecule where only we have cis as opposed to a trans double bond. The other option, which is a newer one, is to use nickel boride. So you might see on your homework or on an exam either H2 palladium and Lindlar's catalyst or nickel boride, and both of those would indicate to you that you're stopping at the alkene as opposed to going all the way to the alkane, which is accomplished with just excess H2 in the presence of palladium. So again, we're starting with an alkyne for this reaction, and because of the nickel boride or Lindlar's catalyst, we're able to stop at an alkene. Because this is a syn type addition, a simultaneous concerted addition of H2, it's going to add to the same side and give us a cis alkene. So this has been a look at the hydrogenation of alkynes. If you like this video and found it helpful, please like, subscribe, and share with your friends.